Hello and welcome to the next in the series of product design and manufacturing collections, Inventor add-ins. Today we're going to look at Inventor Nesting. In today's presentation we're going to focus on a section of the snowplow on screen. Each of these components is a sheet metal component and has a flat pattern assigned. There are many different ways of starting off a nested project. We're going to just right click on the assembly and start project, selecting a default template. The utility will now run through and categorize on type and thickness of the material. The nice thing once it's finished translating is that you will see each individual component in the utility and color coded depending on the material thickness. And the other nice feature, once the program has finished translating the data, you can click on each individual component and it will zoom into that item. By merely clicking on the assembly, all the items will come into view. We will now create a nesting study. Adding the relevant information to our study name, the job quantity, and including any information we wish to include within our study. Checking we have all the outputs correct. We can now click OK for the nesting utility. This is where the utility will take each individual component, setting out the components on each individual sheet. The first two sheets are shown with errors for fit. We're going to be just focusing on Nest 3 for this presentation. The automated nesting has an efficiency rating of 48%. We can go in and change those and edit the nest depending on if we want to increase that efficiency by rotating, moving, mirroring the components, etc. And we can do this all inside the Edit Nest dialog box. But I'm happy with that, so let's proceed. Next we do a report generation. In this full report we can gather all the information regarding our nest, filtering out our properties, our components, what's included within our inventory, and all the properties assigned to this particular nest. We can save this out in a HTML format and give it to the relevant parties. Now let's take this to the next step. The majority of the time when dealing with plasma or laser cutting, DXF is all you need. And right inside the nesting utility we have the option to export each sheet as a DXF. For the purpose of this presentation, we are now going to use the Create 3D Model tool to push our 3D flat pattern directly out into an Inventor assembly so we can use our 3D profiles in the Inventor CAM environment. Check out last week's video for more information on Inventor CAM. Now we've run through the steps of setting up our CAM simulation. First off, let's specify our stock as we would normally. We can also specify what type of operator we're looking for. In this instance, we're going to go for cutting. We now can select our world coordinate to be the bottom left-hand corner of our stock. You will notice that this is misplaced. However, when we start selecting our components or profiles, the stock will readjust as well as repositioning the world coordinates. Now we're happy with our stock. Let's select the 2D profile cutting tool to help us specify our profiles. Now we have multiple types, laser, plasma or water jet. We're going to select laser cutting and the option of through to auto. We'll then select one face, and rather than going around selecting every profile, we can just select the same plane faces option, automatically selecting all the profiles within our stock. Let's now simulate to check our results. Tweaking the settings and playing the simulations, we are now happy. Once we're completed with the simulation, we can export the G-code to the relevant machines. I hope you found this presentation useful. Please join me next week for Product Design and Manufacturing Collection Inventor Add-ins, Inventor Nesting.